Hello everyone, welcome to the second episode in the Arduino tutorial series, where today we're going to be learning about the basics of the Arduino microcontroller and how to use a breadboard. Firstly, to start off, one of the key concepts that you should be familiar with is the input, process, and output control loop. The Arduino works on this basis, and you, if you realize it or not, will depend on it. This is how all Arduino projects are formed, they all use this control loop. Now, to understand this control loop, let's take an example, the LED and push button example. We can think of the input as the push button. Every time you press the LED, the push button, you'll send a signal or data to the Arduino. So that's your input. The Arduino will be your process. The Arduino will understand that you've pressed this button, and based on whatever program you've written, the Arduino will understand what to do with that input data and hence will send a signal to the output. That's all the Arduino does. It processes inputs and based on those inputs it delivers outputs, or it sends signals to components that then produce an output. Then your output is your LED. That will cause, so whatever signal that the Arduino sends, that will cause the LED to turn on. That is your output. So it's a very simple concept of an input, process, and output, and it's very fundamental to the Arduino's function. Now, you've just bought your Arduino, and it looks something like this. Now, you need to know what each of these pins do, and the different connectors, and the big red button. So, this gray port is a USB connector. This is what allows your computer, which you program on, to connect to the Arduino via USB cable, and you can upload whatever programs you've written to the Arduino using the USB connector. Then you have your power connector. Once you have a program loaded onto and uploaded onto the Arduino, you can supply power to the Arduino using a power adapter, which you might find in your kit that you bought. Next, you have your reset button. So once you've loaded in your program, if you want to start your program from the beginning, because the compiler, which is what translates the program, reads line by line, your reset button can restart the program from the first line. Then you have your power pins. So the main ones that we need to know for now are 3.3 volts, 5 volts, and ground. So the 3.3 and 5 volts, they're pretty simple. They're just the power that can be supplied to the breadboard, and you can think of ground as, for now you can think of it as something that will enable you to complete your circuit. Next you have your analog pins. These are specifically analog input pins. These allow for the inputs. Now if you remember from the previous slide, the input, that can be the analog input pins. Next, you have your digital pins. These digital pins go from 0 to 13, and these can be output, so you can connect an LED to it, and based on whatever program you've written there, that'll cause the LED to turn on, or it can be an input, a digital input. The main difference between analog and digital is that analog can be any number of values, whereas a digital can only be two values, a 1 or a 0, or in Boolean terms, a true or false, or high or low. It's only those two combinations for digital and any number of values for analog. Now, the digital pins can be output, so that's your LED output, or they can be input. They'll only accept inputs that are 1 or 0, whereas analog input pins can accept any number of values. You can also have analog outputs, which are determined by this PWM symbol here. We won't go into too much detail for now, but all you need to know for now is that these pins allow for an analog output. I'll explain what those are in a later video where we create analog output to control the brightness of an LED, but for now, that's all you need to know. Now, prototyping projects. In any engineering construct, or in this case, Arduino projects, we always want a prototype. So, what is a prototype? A prototype is a simple and first version of a project or a design, and it's usually done to check to see if the project or design is going to work. There's no point soldering loads of circuits and using lots of expensive components to all find out that there's something wrong in the wiring and the idea will not work. To counteract the waste of time and materials, we use a breadboard and pins that you can push into the breadboard, and these can help design circuits to make sure that your idea will work, and once your idea is working, you can then solder wires together or even get a custom PCB, printed circuit board, for for making your circuits. Now this is a breadboard. It might look a bit confusing, but it's essentially just a plastic case with these slots, 5 along each row here, labeled 1 to 30, and then these 2 long power buses here. So these are just slots where you can push your wires into, and that'll connect that wire to the breadboard. And then these metal strips, which come into contact with the end of the wire, these are known as contacts. Now the function of these contacts, as you'll see in a later video after this PowerPoint, is to make sure that if you connect a wire, say here 19 and the first slot, the rest of these 19A, 19B, 19C, 19D, 19E, they'll all be connected to each other because metal is a conductor of electricity. If electricity flows through one wire here, and if you plug in another wire, say here, then that wire will have the same voltage and current as the other wire that you plugged into 19A. So this is really useful for components. So if you have, for example, an LED and you want to put it on your breadboard, you can take one wire to the 5 volts and one wire via resistor to ground. Don't worry, this will all become clear soon in the next video, where I'm going to teach you the Arduino IDE and our first major project in terms of programming and hardware. Next, you have these power buses. So they essentially work the same way. These contacts or strips of metal will connect vertically rather than horizontally here. So if you plug 5 volts into the one here positive, the rest of these pins, well, if you plug a pin into them, they'll have 5 volts running through them. Now I'm going to show you a demonstration where I show how the contacts work with a multimeter and the continuity between the slots of pins. To test the contacts and the conductivity in the breadboard, we can use a multimeter which has a conductivity setting down there, and that allows us to, so if I put these two pins together, we can see that they have electrical conductivity and a buzzer sounds. So based on this information, what we can do is we can use the contacts we can determine how the contacts are located on this breadboard and how they're going to be useful when we're creating and designing circuits. So this is the power bus, and the contacts, as you might remember in the PowerPoint, run vertical for the positive terminal and the negative terminal. So if we connect this yellow wire as if it's 5 volts from the Arduino, and we connect this blue wire, and if we connect it here, the buzzer sounds, which means that they're connected. So 5 volts coming from here will ultimately lead to 5 volts coming in the blue wire. So that's how the contacts work there, and it's the same story for the negative terminal. Now,
for the pins, so the rows A to J with this split in the middle, they all have their contacts running horizontally. So, and they're not connected over the middle part. That's so that you can attach buttons which require a bridge. So let's test out this one here. Imagine that this is a component, for example an LED, and we want to send the digital value of 1, or the high signal, to turn it on from the Arduino. Now we can do this by connecting this blue pin to it, and there's the buzzer, which means that these are electrically connected. So if we send a high voltage to this wire, automatically in the yellow wire there will be a high voltage turning on the LED. And that's the basic principles of a breadboard.